Hello friends, welcome to the channel. Today's problem is minimum days. Here we are given a string s of length n containing only lowercase alphabets. We are also given a permutation p of length n containing integers from 0 to n minus 1. In I plus 1th day, you can take pi permutation value pi value from the permutation array and replace spi with a question mark. For example, in day 1, we can choose index of permutation as equals 0 and replace sp0 with a question mark. Similarly, in day 2 and day 3 and so on. After performing these many operations, you have to tell the minimum number of days required such that after it, all the indexes of I should be, if si is not equals to question mark, then si should also not equals to si plus 1. What that means is we should not have any adjacent repeating characters. Suppose in this example, we have a, b, b. So here A and A are adjacent and repeating. So we should not have any duplicates adjacent to each other. Similarly here B and B. So we have to remove these A and B with a question mark and hence we'll get our answer. So here in day 1 we replace SP0 with a question mark. After that the string S would be AA question mark B. As we can see, S still has character A at the index 0 and 1. So in day 2, we replace sp1 with question mark. After that, string s is equals to a question mark b. As we can see that the string has for all indexes I, if si is not equals to question mark, then si is not equals to si plus 1. So it means we should not have any repeating characters, but question marks can be repeating. So question mark can repeat, but not any other character. So the approach for this problem should be, what we will do is we will first count the repeating elements. For example, in this string we'll count, see we have one repeating here and one repeating here. So the repeating element will tell us whether how many days we have to perform the operations. And once we are done with that, also one more thing we need to focus on. Firstly, there are two elements of this, there are two components of this problem. Firstly, we need to address the non-repeating adjacent. Now to remove that we need to perform the operations, but this the order of this operation will depend on this permutation array. We are given a permutation and we'll move in that according. It travels from 0 to n minus 1, so but our movement would be restricted in this direction. First we'll clear the second element, then we'll go to first element, then we'll go to third element and so on. We have to follow the permutation array. So if we had to do it ourselves, it will just take two. Suppose to remove two elements, it would take 2 days. But if following the permutation array, it could take 3 or 4. Suppose one was not here, one was not here, and three was here. So if it would have been 2310, then we would have taken 3 days. I hope it is clear. So let's try to solve this. Let's write the algorithm first. What we have to do is count the number of repeating characters, repeating adjacent character. Repetition should be an adjacent. So we can have similar characters at multiple other places, but they should not be adjacent to each other. Okay, we'll count the repeating adjacents, and if it is 0, if count equals to 0, then return 0, else we'll follow permutation array and remove repeating elements. If round becomes 0, then that index of permutation array would be our answer. Suppose, let's take this example number two. We are given an array of four characters or a string of four characters. Here permutation is 3021. But we'll see that there's no repetition. So there is no repeating element, then count would be 0 and that would give us our answer. Now in this array, we remove the repeating elements after the second element. So 0, 1. So we'll have to do answer plus 1 to get our answer. So we'll do it answer plus 1. I hope this is clear. You can try the code yourself. And then if you stuck somewhere, then come back to watch again the explanation or the code. So let's start writing the code now. So what we will do is first we will try to convert there are multiple methods to address this string problem or string manipulation, but I believe this would be very easy if we just convert because it is given we have to insert at a particular character, particular index. Suppose we are given a string and we have to insert a question mark at this location. For that, it would be easier if we convert it into an array. So we have a method in Java string class, which returns the character array if called upon a string. So it is to char array. This method gives an array of characters. We got the character array, so we'll count the repeating element. For int I equals to 0, I is less than n minus 1, we won't have to check for the last element, and I plus plus. Now if ch I is equals to ch I plus 1, then count plus plus, we have to create a count variable. Now if count is 0, then return 0. Else count is not 0, then we'll have to calculate the answer. So initialize it with 0, start a loop. This loop is for the permutation since the length of the permutation is also n. So we'll run it till n. Int I equals to 0, I is less than n I plus plus. Now we will take a variable temp where we will store the value of permutation here. This is for the easier understanding. We can also use pi at various places where we will use temp, but for the better understanding we'll take temp. Now we have taken the permutation. We have to check whether at the particular location whether the left element and the right element is equals to the or similar, whether suppose we are given a location I equals to some location. So we have to check whether I plus 1 and, and I minus 1 are not similar, whether these three are similar or not. If anyone is if I is similar to the left one or the right one, we'll decrement the count, and if all three are similar, just inserting question mark at this location will solve our problem. That is why we'll check for this. But for that, we'll first have to calculate whether our I is within the range of this temp array, or within the range of this permutation array, which is stored in temp. So we'll check temp minus 1 for the left element is less than equals to 0. It is not getting out of bound. We have to check that, and once we've done that, we'll check ch temp minus 1 double equals to ch Then if it is so, then we'll decrement. Now again, we'll check for the right element. For the right element, the index would be 10 plus 1 should be less than n. It should not go beyond the right side of the array. Ch temp double equals to h temp plus 1. If it is so, count minus minus. And once we have checked that, we'll insert the question mark at the particular location. Ch temp equals to question mark. This is it. This is the operation we have done. Now we'll check whether if count equals to 0, when there are no repeating element left in the array. So what we'll do is we'll store answer equals to I plus 1 and break the array. We don't need to perform anymore. That's the end of the operation. Here, return answer. Let's check whether this works or not, or if I've done some error somewhere. Yeah, it works. Nice. So this is the approach and solution. Out of bound at 84. This is going out of bound. Oh, sorry. It should be greater than. Sorry. Now this should work. It should be greater than 0. No? That's my bad. It works, and that's why we check this, because it will go bound. So now you understand the importance of this. So that was the explanation. If any part is not clear, do ask in the comments and stay tuned.